Thank you, Daniel, for the introduction. I mean, I wouldn't call it Europe tour. I just have to work at different places at times. Anyways, hi, good afternoon. And today I'll be talking about what I call LLM washing, and also when you might actually want to prefer a non-LLM model over LLMs. So yeah, Daniel actually said already half of what's on this slide here. So I'm a machine learning engineer at Pure App. It's a dating app, and there I work at the recommendation algorithm. So basically, who's going to be showing at your feed, but also moderation-related topics. My main expertise, though, is natural language processing. So everything that's got to do with language and machine learning, and a domain of that are LLMs. So that's what I do at day. At night, I also work or freelance as a course instructor at O'Reilly. So I do online courses and webinars there. And since this year, I've also been selected as an ambassador for the Google Women Tech Makers. So this talk, again, is going to be about the question, so why are LLMs actually so hyped? So yeah, they're great, but why are they hype? Why are they actually so great? And then also when it's actually time to look beyond LLMs and pick a different non-LLM machine learning model for your use case. And for this talk, so first I'll be talking about the so-called LLM washing trend, as I call it. Then we'll be looking beyond the LLM. So what else is actually out there? What other machine learnings than LLMs do actually exist? Then I'll be walking you through some real-life examples that I did at home in preparation for this talk, where I weigh LLMs against other non-LLM machine learning models. And then we'll be talking shortly about how to actually choose the right model for your use case. So let's talk about the LLM washing trend, or also the rise of LLMs, as I call it. So we've been talking about LLMs all day long. So by now you might have a basic understanding of what they actually are, or some more, right? So, but in a nutshell, just to repeat it for good measure, large language models are AI models that are trained on vast amounts of data with the goal to understand and then also generate human-like language. Examples of that are GPT 1, 2, 3, 4, 4.0, all of those ChatGPT models are models by OpenAI, but also Llama, Bird, there are literally thousands of them. And the question is, so why are LLMs actually so popular, right? So AI has been a hype for some time, but since the advent of ChatGPT, LLMs are everywhere. Everyone is talking about LLMs. Everyone wants to use LLMs. So why is that actually the case? And here I have identified 3 reasons for that, the German 3. So one of them is versatility, right? So as Anand already mentioned in his talk, so LLMs are great for generating language. So we can use them to summarize, we can use them for creative writing, we can use them for all sorts of tasks that include, well, generating any sort of language, right? So they're incredibly versatile models because they're designed to be generalists in what they're doing. Another one is the media attention, right? So maybe the first time you've heard of LLMs was probably about 2 to 3 years ago when ChatGPT emerged, right? Due to OpenAI, who put this model out there, or this tool out there with this nice UI front that you could start chatting with some AI. And this is when all of this started gaining attention. So the media attention has been focused on LLMs very heavily for the last 2 to 3 years. And then another reason why LLMs are so popular is their ease of use, right? So we have this nice chat UI. You can ask a question, it generates an answer. So even for people with lesser technical knowledge or skills, it's super easy to interact with those LLMs and make them do stuff. So the key message here is, well, LLMs do have revolutionized various industries, from customer service to creative writing, but it has led to overuse and also misuse of those models in comparison to other machine learning models. And what that is, I get to in the next slide. So what is this LLM washing actually? So it's actually a term that I coined, so I'm not sure it exists out there, but it's kind of in parallel to like greenwashing or anything, right? So these models are seen as cutting edge, right? Because they show really impressive results. So it's almost like companies are trying to use them as a prestige for themselves. So, oh, we're using LLMs now. Look, we use AI now, right? So they're almost used as a sign to other people, to competitors. Oh, look, we are at the cutting edge of technology, right? And this leads to an overuse of those models and also to a one-size-fits-all mentality, right? Because they are so general, they can solve so many tasks at once. We have this mentality, okay, they can just solve every problem that we have. Why would we actually ever use another model to solve anything anymore? And there are consequences to this, right? And there are two major consequences. One of them is inefficiency. So LLMs are really, really big, right? So we've learned that they contain these parameters and they are calculated in billions. So to run an LLM, a large language model, we need a lot of computational power. We need lots and lots of GPUs so big computers, kind of powerful computers to run them. This costs a lot of money, right? So if we use a model that is smaller, but more specified to the task, it's going to use less energy, right? So our builds will be smaller. Another consequence of LLM washing is suboptimal results. While LLMs are great generalists, they're terrible at domain-specific tasks. So when I copy-paste an email that I got to an LLM, be like, hey, is this spam or not? It might give you the right answer. But there are a lot of models out there that are fine-tuned, that are specialized to figure out whether this LLM was spam or not. So while we pay a lot more money to use LLMs, it might also decrease the accuracy or the performance of the problem that we want to solve, because we simply have more specialized models out there that are actually trained, they are fine-tuned to solve this specific task. So while LLMs are super powerful, I love them, I use them every day, it's crucial to recognize when to use LLMs and when to use other models. So let's look beyond LLMs. And this talk is also partially built out of my own suffering. So as a machine learning engineer, my product manager sometimes comes up to me and is like, hey, Lisa, can we use LLMs for this use case? And I'm like, yes, dear product manager, but look, it's going to cost us a lot of money, right? So we can, but money. And she's like, well, how much money? Just tell me. So I'm taking my abacus or my, calculator. There is no calculator emoji, but there's an abacus emoji. So I'm taking my abacus. And I tell her it's about $60,000 a day. But we can build actually a customized solution with a non-LLM machine learning model for about $250 a day. And for who is as bad as I am as calculating stuff quickly in your head, it's a factor of 240. Right? This is the amount of money we could save by just being like, hey, Lisa, we give you a month to develop this instead of a day to put an LLM into production. And this is the amount of money we would save, a factor of 240 per day. That's just a conversation that happened like 2 weeks ago. So yeah, it is a pain point. And it's not just me, it's a lot of companies where this is happening at a time because LLMs are easy to understand, right? We see how powerful they are. So it is easy to think about your problem, about your pain point, and then be like, okay, we can probably use an LLM to solve this, right? Yeah, we probably can, but money. So there are so many machine learning models out there that are not LLMs. And the key strengths of those non-LLM models, and it's kind of a repetition of what the disadvantage of a misuse of LLMs are, is, so one of them is interpretability. Right? So as we've heard from Rachel Lee, from Anand, from all our other great speakers, is so we give it some input and we get some output, but this output is not necessarily predictable, right? It's very often random at times because those LLMs are kind of big black boxes that we get stuff in, we don't really understand what's happening, and then something comes out. So interpretability is a big factor why we want to use simpler models, because it is easier to figure out how they actually got to their model output in comparison to LLMs. Another one is, efficiency. I mentioned this before, right? So if we choose a non-LLM model, we can save a lot of money, right? And then also the domain-specific performance. I mentioned this before. Our accuracy or whatever you're measuring can increase greatly if we use a model that's actually built to solve your specific problem instead of just throwing an LLM at it and being done with it. So, yes, so you might have heard of Hugging Face. So it's not just this cute emoji, it's actually a big player in the machine learning world. Hugging Face is a platform where everyone and their dog can upload machine learning models. So this might be models that they built themselves, or this might be models that they took from somewhere, fine-tuned it with their own data, and then uploaded it there. And I took this screenshot of the amount of models that are on there just last night. And there are more than 1 million machine learning models on this platform. Or actually, to get more detail, thank you, Anand, for explaining the difference between deep learning and machine learning models. On this platform, actually mainly deep learning models. So there's even more models out there than those 1 million on Hugging Face. So we have so many models to choose from. Why not look at our problem and pick a model that is far more, that suits our problem far better than a large language model. So what are these models? So I mentioned before that my main expertise is natural language processing, so anything that's got to do with language and machine learning. And LLMs, which is text generation, that's just the one tiny subclass of what natural language processing is. But next to NLP, there is computer vision, so this is like anything with images or anything with video. But then there is also tabular data. So if you think about your Google Sheets, your Excel tables, that is tabular. This is tabular data. Then there is also audio, of course. So if you think about transcription or what's happening here on the side, right? This is also partially machine learning. It's taking my audio, what I'm speaking right now, translating it to text, and then being corrected by the nice gentleman in the back. And then we also have reinforcement learning, which was also introduced by a couple of speakers today. Thank you for that. There is also multimodal models, right? If you go to ChatGPT or another platform and you're like, hey, generate a cute-looking llama for me, right? You input text, but it outputs an image. This is what you call multimodal. We have multiple modalities in there. Then there are also, well, a category other. For instance, graph machine learning models, which you can imagine, for instance, at dating apps like Pure App, where we try to represent every user as a part in this graph, connecting to other users by sending likes, by connecting with them, etc. So those are graph neural networks. So there's a huge variety of models out there which are built to solve specific problems. So let's try to talk about some more popular categories of these models. So there are predictive models. They are mainly for sequential data. And you can think about sales prediction, but also the weather, right? London, it was probably around 15 degrees the past few days and was raining. So the chance of it tomorrow also being 50 degrees and raining is a lot higher than tomorrow it being 30 degrees and sunshine. So this is kind of how these kind of models work. They take the data from previously and try to predict or infer. We learned what inference is just in the lingo bingo, what's coming next. So you can use this for sales predictions, stocking your items, this kind of data. We have classification models, right? Maybe the easiest to understand use case here is spam detection. You have an email, you want to know if it's spam or not. Usually Google Mail or whatever you use does a pretty good job at doing this out of the box. So they're using classification models to figure out if what you receive is spam or not. We have clustering models here. You can think about market segmentation. So you have your users. Maybe you want to group them into, I don't know, those are my readers. I'm going to, I don't know if you're Amazon or some seller, right? Those are my readers. I'm going to recommend more books to them. Those are my gamers. So they're going to get the video games and so on. So you're trying to cluster your user base or whatever data you have together in order to make recommendations or whatever else your use case is. And then another example that I have here is anomaly detection models. So this is very popular, for instance, for fraud detection. So let's say you are a bank and you have ATMs everywhere, right? And usually in this ATM, in that corner of the city, the amount of money that is withdrawn from this ATM is between this and that amount of money. So if somebody comes by and suddenly withdraws an amount of money that's 5 times higher than your average max, then usually probably something is off, right? So this is an outlier and anomaly. So this is what anomaly detection models do. So those are just examples of types of models that you can use to solve your specific problem, your specific use case. So let's look at some real-world examples. And this is probably the saddest and funniest part of this presentation, because it was me at home trying to figure out examples for this presentation. And there were some cases that were like really pretty, etc. But I put in the ones with the biggest learnings, but they're also the funniest and the saddest. So bear with me. So the first use case is, so I took a publicly available dataset of SMS, around 5,000 SMS from the so-called SMS spam collection dataset. And each of these SMS has a label attached. Is it spam or is it not spam? So you might have an example here on the left is, I have a date on Sunday with Will, and this is probably not spam, so it has not spam label attached to it. And then XXX mobile movie club, to use your credit, click here with some weird symbols. This is probably spam. So we have a data set with about 5,000 of these classified into spam and not spam. So the idea is here, can we classify? So can we just look at an SMS without looking at its label and say if it's spam or not spam? So kind of like closing your eyes and then saying, okay, is this spam or not spam? So I first did this at home, trying to solve this problem, right? And there are a couple of words on here which do not matter too much, but I still want to use them. So what I used to solve this is a so-called multinomial naive Bayes classifier. You can read this and then forget about it again. What I want to let you know, though, is just an old and very popular machine learning algorithm for classification tasks, so exactly what we need for this. The code to solve this problem with this algorithm took me about 30 minutes to write, so really not much, because it's a very well-known, well-documented, very easy to implement algorithm. The results were ready in 30 seconds, so basically executing the code. And it's about a 96% accuracy. That's a very good result. So yeah, case solved, great. And then I took this and threw it into ChatGPT and tried to figure out what it does. So this is basically now the non-LLM solution, right? I took this multinomial naive Bayes classifier to solve this problem, but then I wanted to figure out how an LLM fares in comparison to that. So I took some of these SMS with their label and threw it at ChatGPT and was like, okay, now build me something that then can predict on an SMS without a label if it's spam or not spam. And what it did was kind of surprising, kind of unsurprising. So what I expected first is that it just tells me, okay, this SMS is spam, this SMS is not spam, but instead it just spit me out the entire code. And maybe terrifyingly, scarily, it's almost the exact same code that I wrote, right? Because this is a very popular model. People have been writing Stack Overflow posts about this for decades at this point, right? So what it wrote here is also a multinomial naive Bayes classifier, and even the result was almost exactly the same of what I did. So the ChatGPT, instead of just telling me, okay, this is like spam or not spam, it just gave me the code for that. So it kind of worked, but was not what I actually wanted it to do, right? So it gave me just the code to build my own algorithm based on that. But the learning from here is, even though it didn't listen to me, but maybe it was a language barrier problem, I'm not sure, I'm not a native English speaker, ChatGPT can work well for code assistance, and I personally use LLMs, not ChatGPT, but LLMs for code assistance almost every single day, right? They can work greatly on help you debugging code, for instance. Okay, so this one example where it kind of worked, but also not kind of how I wanted it to work. Then another example, sales prediction. So this case is a tiny bit more complicated, but bear with me. So I also took an openly available data set, I can't read the name, time series practice data set that's openly available online, open sourced. And this contains 10 years of sales data where we have the date of when something was sold in a particular store of a particular product. So we have 845 apples sold in store 8 on the 1st of January this year. And this is the kind of data we have in a table, right? This is tabular data. So we separate these 10 years of data into a so-called train set. This is what we throw into the machine learning algorithm to train, to learn. We take 9 years of that data. And the last year, so basically the latest year, 2019, we take away as a test set. So when we have our algorithm, we ask it, okay, now don't look at how many things were sold, but tell me, right? Try to predict how many items we sold in the year 2019 per item per store. And this is where ChatGPT, like my conversation with ChatGPT was very frustrating, but also so funny in the end that I had to put it on these slides. All right, but first I solved this myself, right? So for this, I took a so-called long short-term memory algorithm, and I think it was Andy who talked about this for a second, so also you don't have to even remember this word, right? It's just a very popular and rather old traditional machine learning algorithm for sequential data, right? If you remember from 5 minutes ago, sequential data is when we take data from the past, like, I don't know, in summer we sold more apples than in winter. Do we now sell more apples in summer or in winter the next year, right? So we take information from the past to predict information in the future. So this code, again, was written about 30 minutes because it's a very simple algorithm, very simple to implement, so saved my time here. This code was executed in about 1 minute, so again, very small algorithm, very simple to train. And the result was about 0.13 of a mean squared error. I'm not going to go into detail what this exactly is, but it says error, so the smaller the better. So this is also actually a pretty good result, right? And then I took this data and threw it into ChatGPT, and that's where it got funny. So I was like, okay, look, you're a sales prediction model. Here's this trading data from 2010 to 2018. Please now predict how many items were sold in 2019. And I'm pretty sure this was some sort of language barrier because it just told me how many products were sold in total across all stores, across all products in 2019. So, okay, I'm going to give that to ChatGPT. That was me not being clear enough of what I wanted. So it told me, okay, about like 2 million items. So, well, thank you, ChatGPT, but it's not what I wanted. I wanted to know how many apples were sold in store A on the 1st of January in 2019. So, okay, so I clarified. Look, I want this data that you give to me back in the same format as the input data. So I want it per store, per product, per day. But then it just gave me the average, right? It just told me, okay, look, Lisa, you have now 300,000 items sold per day, per product, per store in each day. Yeah, no, also not what I wanted, right? Don't average it to me, tell me on what day I'm selling which product that amount of times. So I try to be even clearer. Maybe it's me, maybe it's my English, maybe that's the problem. So I try to do it to be even clearer and explain it more to ChatGPT, and then it started. You know, like it gave me this spinny wheel, and it did it for like a couple of minutes, and then told me, "I seems there was an issue with the connection." No, my internet was fine, GPT. This was you. So it said, "Let's get back to it," and it gave me the spinny wheel again. And then it told me, oh, it appears that the process was interrupted again. I just tried to break it down into smaller bits and pieces. Then it was again paused. It seems that the execution keeps getting interrupted. Well, GPT, yes, I noticed. Thank you very much for this piece of information. And then it told me, well, I give up here, but these are the next steps that you can take if you want to. Like, oh, thank you for that. Yeah, here's the code, just do it yourself. Okay, thank you. If you need further assistance or a specific part of the code, feel free to ask. Yeah, that's what I asked for. I didn't get it. But I think ChatGPT at this point felt so bad that it just outputted me some pretty graphs afterwards as well, without me even asking for it. So it gave me a pretty graph of the total sales per store. So each column here is one of the 6 stores that we had the data of. And the Y column here is the amount of items that were, well, the amount of sales per store that we had. And I then plotted the data myself, and it was actually exactly the same. So, well, thank you, ChatGPT, it's something. And then it also outputted me the total sales per product. I was like, okay, well, thanks for nothing, I guess. But the takeaway from here is, well, ChatGPT can at least work well for data visualization. I guess that's some takeaway. Whew. Okay, but moving on, how do we actually choose the right model for our use case? And I could be talking hours or days or even weeks about this, but what I want to give you now are just some questions that you have to ask yourself, whatever your role is in the company, if you're involved in like new products, your stakeholders, the data or machine learning people at your company, or basically the consultants you might work with if you don't have those people in-house. So one of those questions is, and the most important I might add, is what problem are we actually trying to solve? And this is defining your business problem. Most of you will be very familiar with this, right? But this will already tell you if an LLM, or probably tell you if an LLM is actually the right choice for this, right? So you have to clearly define the business problem. So are you trying to predict future sales, classify customer segments, detect anomalies, etc.? There are probably very specific models that were built to solve your problem. So if you're looking for forecast sales, as mentioned before, you need a predictive model. You could try to use ChatGPT, but don't, because you just learned what it did with me. Secondly, and this is also the garbage in, garbage out that Rachel Lee and a couple other people mentioned already, is, do we actually have the right data, right? So there are some machine learning models that work perfectly out of the box for your problem, but they might not, right? The data you work with might be very specific, like a very specific jargon if you work in law, for instance, or in medicine, right? So those models that exist on Hugging Face or anywhere else, they might not know the specific jargon or the specific type of data that you're using. So in this case, you might need to use your own data to fine-tune or to train a model to customize it. And it can be very cost and time intensive to collect this data if you don't have it, or to label it if it is not labeled yet. So those are all questions you have to take into account when you're choosing your model, if you're choosing your approach to solve your problem. Then we also have the question of what are the computational or the cost limits. If your company doesn't care how much money you put into your solution, well, then you might try it with LLMs, right? But if you're very restrained on your budget, you might want to try it with a very simple model like I did with this LSTM and this multinomial naive Bayes. Maybe these are actually good enough, right? So you might have a trade-off in performance because these are extremely simple models, but they're super easy to implement. They run extremely fast. They're very low in maintenance. So it's always a trade-off between those two. Then, how quickly also is the solution needed, right? So how much time do your people have to do exploration, right? So first you have to gather the data, and then you have to test some models, right? And depending on how much time you have, you might want to go for something that might be more expensive if you have less time, right? But fine-tune that and then be sure, okay, we can put this into production, right? But if you have more time, you might want to look into optimizing the probably ideal model for your use case. So it's a trade-off like between all those questions. It's a long and elaborative process to reach a solution to this question of which which machine learning model to choose. And then the last question is, do the stakeholders actually need to thoroughly understand what's happening behind the box, right? LLMs are black boxes. There are a lot of other machine learning models that are also very big black boxes, so it's very difficult to say how this model actually landed at the output that it predicted or inferred or whatever. So if interpretability, if explainability is extremely important, you might want to go to a model, thank you, that is easier to explain. So I'm sorry, I cannot give you like the solution to what is the perfect machine learning model to solve your problem, but those are questions that you have to ask yourself and the stakeholders in your company and anyone involved in the project, ideally, or at least the core team, to make a decision of which model to choose. All right, to recap, LLMs are great. I love them. They are great general purpose language models, right? They're trained to understand us and to, well, parrot back at us. But there is a nut for every bolt. And so the key takeaway here is please do not just rely on LLMs, check out other models too. And choosing the right machine learning model can be, well, is a very sophisticated process, and it depends on many factors and how much time and effort you're putting into this. There are a couple of other topics to consider when building AI systems, and I just want to summarize them very quickly. Model evaluation and validation. So just picking the right model is not enough. You have to monitor it, right? You have to evaluate it. You have to keep evaluating it because things can change over time. Just putting it into production is not enough. And then forget about it. Then there's this whole other thing around it, which is called MLOps, so model deployment, right? Feeding in new data, maybe retraining your model over time. So these are all just other factors you have to take into account when talking about, when developing a machine learning project. And then lastly, of course, there are always ethical and regulatory considerations. If you work with personal identifiable information, for instance, you're probably under GDPR, and there is also now the EU AI Act, so the riskier use cases, medical use cases, for instance, you definitely have to look out for what kind of regulation applies to you. All right, with that, I want to thank you for your attention, and I'm ready to take questions or conversations in the hallway right after this talk. Thank you.